Welcome back. So in parts 1 and 2, we did a deep dive into the theory behind AI agents. Well, today, that all changes. We are putting the theory into practice. This is the part you've been waiting for. We are officially done just talking about agents. It's time to build one, right here, from the ground up.
That's right. No more hypotheticals, no more abstract concepts. We are jumping straight into the code. And my promise to you is this: by the end of this explainer, you will have a fully functional AI agent running on your own machine. An agent that can perform real, actual tasks for you.
Okay, let's dive right in. We're going to build an agent that's simple on the surface, but incredibly powerful underneath. It's going to do two things: perform math calculations and tell you the current time. Now, don't let that simplicity fool you. Think of these as the agent's very first senses. The fundamental principles you're about to learn here, they're the foundation for every single complex agent you'll build down the road. So, let's get to it.
All right. First things first, every builder needs a workshop, right? So go ahead and fire up your code editor and create a new file. Let's call it agent.py. This is going to be our home base where we'll assemble our agent, starting, of course, by importing all the essential libraries and components. These are our building blocks. We're going to be using a framework called LangChain, which is pretty much the gold standard for connecting language models to external data and tools. And from it, we're pulling in some real heavy hitters. You've got Agent Executor, which is the engine that actually runs the agent. Create React Agent is the factory that assembles it. Tool is how we give our agent its superpowers. And Hub lets us just easily grab pre-made, battle-tested prompts. It's a huge time saver.
Next up, we import Chat Anthropic. This is the direct connection to our agent's brain, the Claude language model itself. We're also going to need two standard Python libraries, os and load_env. And look, these are absolutely crucial for managing our API keys safely and securely. They let us load our secret keys from a separate file, so we never, ever have to hard-code them directly into our script. Super important.
Okay, our workshop is all set up. We've got our tools laid out. Now it's time to give our agent its mind. We're going to create an instance of the Claude large language model, which is going to handle all the heavy lifting, all the reasoning and decision-making for our agent. So let's take a quick look at the parameters for our agent's brain. Now, the most important one here is temperature. We're setting it to 0. Why? Well, when an agent is deciding which tool to use, we don't want it to get creative. We want it to be predictable, focused, and deterministic. A temperature of 0 ensures it picks the absolute best tool for the job every single time. And of course, you can see we're loading that API key securely, just like we planned. So, we have a brain. But a brain that can only think and talk isn't really an agent, is it? To be a true agent, it needs to be able to act. And this is where tools come in. This is the fundamental difference between standard generative AI, which just creates things, and agentic AI, which actually does things. We're going to create our first tool, a simple calculator. And it follows this really beautiful 3-step process. First, we just write a normal Python function that does the actual work. Second, we wrap that function in a LangChain tool object. And third, and this is the important part, we give it a crystal clear description. I honestly cannot overstate this point enough. The quality of your tool's description is probably the single most important factor in how well your agent performs. The language model has no idea what your code does. It only reads this description to decide if this is the right tool for the job at hand. A great description is the secret to a smart, reliable agent. Okay, let's follow that exact same pattern to create our second tool, current time. We define a simple Python function that gets the current time, and then we wrap it as a tool with another really clear, unambiguous description that tells the agent, hey, use this tool when you need the current date and time. It's simple, it's effective, and it's a repeatable pattern you'll use over and over. All right, the pieces are ready. We have the brain, and we have the superpowers in the form of tools. Now it is time for the assembly line. Let's put all of this together into a single functional agent. You can think of this exactly like a recipe, right? We're taking our 3 key ingredients and combining them. We've got our Claude LLM, that's the brain. We have our list of custom tools, those are the superpowers. And finally, we have the instructions, which come from a special prompt that we're just going to pull from the LangChain hub. Now let's look at the code that brings this all to life. It's surprisingly simple. First, we create a basic Python list called tools that just holds our calculator and time tools. Second, we pull down a pre-built prompt from the LangChain hub. This specific one is called React, and it's designed to help agents reason and then act. Third, we pass our LLM, our tools, and that prompt into the Create React Agent function.
This is what assembles the core logic. And finally, we wrap that whole thing in an agent executor. That's the engine that'll actually run the agent. And that's it. 4 key lines of code.
Oh, and one last, really crucial thing we add to the agent executor is verbose equals true. Think of this as a magic window into the agent's mind. When we run our agent, this is going to print out its entire thought process step by step. What it's thinking, which tool it decides to use, what the output of that tool was, all of it. For debugging and just for learning how this stuff works, this is absolute gold.
The assembly is complete. The agent is built. There is only one thing left to do. Let's give it a mission and see what happens. This is the moment of truth.
We're going to give it a prompt that's specifically designed to force it to use both of its tools. See, it can't possibly answer this without successfully using the calculator and the time tool. Okay, it's time to run the script. Let's see this thing in action.
Now, as you watch the output in your terminal, what you're seeing is something called the React loop in action. React stands for reason and act. First, the agent reasons. It looks at the prompt, thinks I need to solve a math problem, and chooses the calculator tool. Then it acts. It runs the tool and gets the result. Then it reasons again. Okay, done with that. Now I need the time, and it chooses the current time tool. It acts again. This loop of reasoning and acting just repeats until the entire mission is complete. It's amazing to watch.
And there you have it. This brilliantly illustrates the core power of agentic AI. You didn't write a bunch of if-else statements telling it how to solve the problem step by step. No, you gave it a goal, you gave it a set of tools, and it figured out the entire sequence all by itself. That is a huge leap forward.
You did it. You have a real, working AI agent that can do math and tell time. But trust me when I say we are just scratching the surface of what is possible here. This is only the beginning.
Right now, your agent is pretty smart, but it's also limited. It can't access live information from the internet, and it has absolutely no memory of past conversations. Well, in our final episode, we're going to fix that. We are going to level up this agent big time, giving it the power to browse the web and remember what you've talked about, turning it into a genuine research assistant that's about to get even smarter.
So start thinking about it. Now that you have this new skill, this new superpower, what tedious task are you going to automate? What problem are you going to solve first? The possibilities are literally endless. So get your code ready because I'll see you in the next explainer where we are going to make your agent even